Hey everybody. We're going to start lesson 7.2 today, which is a continuation of the limits discussion. And what we're going to be doing today is finding limits analytically. So that means not necessarily looking at graphs, not necessarily looking at specific equations, but more like learning the rules of what limits can do as far as like computation. So like how you can take a limit and break it up, how you can find a limit without looking at a graph every time, things like that. Um, so you're going to find on these first two slides like a lot of different rules for what limits can and cannot do. And I'm just going to quickly go through like some of the rules. I'd rather show you examples to kind of reiterate what they are explaining there because they're very abstract looking in nature. And so I'm just going to quickly go through a few of them. Essentially, it's like this. It's kind of like limits sort of do what numbers do. Like you can use numerical properties and apply them to limits. Like you can switch the order in which you're adding them, or you can break them up, or things like that. So I think it's all going to be fairly common sense once I break down this notation. So on this slide, you've got this constant rule and identity rule. I'm going to explain those in some later examples to you. So I'm going to just go down here first. Some difference in product rule. So basically what's going on in these three rules is it's just saying that if you're taking the limit of two functions that are being added together or subtracted or multiplied together, you can make this easier on yourself by breaking it up. And so what I mean is just take the limit of each thing individually and then add the answers together or subtract the answers or multiply the answers. So it's going to allow you to take something complicated and break it into chunks. Okay. So that's your sum difference and product rule. There's also kind of like a quotient rule that goes along those same lines. So if you have a function divided by a function and you want to take the limit of that whole thing, you can just do it, the limit on the top and then the limit on the bottom and then divide the answers. So it's chunking it up. Your constant multiple rule, that is, let's say I have some kind of function here and it's being multiplied by a number. You can take the number all the way out of the limit, like all the way out, just the whole number, not the equation. And you can take the limit of the equation and then just multiply by the number at the end. Okay, I'll show you plenty of examples like that as well. And then there's one more rule called the power rule. So this would be like if you're applying some kind of limit of a function that's being raised to a power, you could just take the limit of the function and then get that answer and then raise that answer to the outside power last. So again, this is all about simplicity. You're taking complicated stuff and making it easier to deal with. Obviously, examples are going to be way more helpful here, so let's just get to it. So these first few questions are very, very abstract in nature, simply just to help you learn the application of these properties. So it says, suppose the limit as x approaches c of f of x is 4. The limit as x approaches c of g of x, which just would be another graph, is negative 3. And the limit as x approaches c of h of x is equal to 9. Find each of the following limits. So you're going to see two of your functions combined together. So again, this is just going to be going back to previous slides, finding the appropriate property and using it. So this one would be a sum property, which allows you to break it up into chunks. And so what I'm going to do is I'm going to separate this and I'm going to say, let's find the limit of f of x as x approaches c. And then let's find the limit as x approaches c for g of x. And then we'll add those together. Now, the information at the top is already giving you the numerical values of those limits. Where last section we would go to a graph, we would find the limit up there, and then we would answer it that way. These answers are given. So what is the limit as x approaches c of f of x? It's 4, says it right here. So this is equal to 4. And then what's the limit as x approaches c of g of x? It's negative 3. So I'm just going to say that the total limit for this would be equal to +1. Easy enough? Okay. Question B is a difference formula or difference rule, is it said, but this also has constants in the front. So I'm going to separate this like I did in example A, but I'm also going to bring the constants to the front. So I would write it as 3 times the limit as x approaches c of f of x minus 5 times the limit as x approaches c of g of x. So when I answer these questions, the 3 is just going to be kind of on the outside for now. Take the limit of f of x, which we already have given to us, that was 4. And then you're going to just multiply it by the outside value of 3. And then the g of x again was -3. So your math would look like this. Obviously, you're going to say 3 times 4 is 12. -5 times -3 is 15, so it looks like 27 would be your answer for that one. Okay, example C, we have a constant and we have a product. So same rules, you can bring constants out to the front and apply them last. You can also break up multiplication and say, let's do the limit of each thing separately, and then we'll multiply our answers at the end. So I have 7 times the limit of f of x, I think that was 4, and the limit of g of x, I think that was -3. So we're going to multiply all these things together. So I need 7 times -12, which would be -84. Okay. Last example with the property rules is a quotient. Actually, and it's got a constant value. So I'm going to do this. I'm going to bring the -6 out to the front. And I'm going to have f of x, and all of that's going to be on the top. And then I'm going to separate and put the limit as x approaches c of h of x on the bottom. Okay, so I have -6 times the limit of f of x was on the top. I think that was 4. And I don't know what h of x was. Let me go look. H of x was 9. So 9. And this would give you -24 over 9. And then you can simplify that by dividing by 3, which would be -8/3. And that would be your answer. Okay, so a couple more rules. I'm not going to do all of these because some are repeats, but there are a few other rules here with like power rule. I think it was called power rule. Yeah, power rule essentially. So we're going to look at a couple examples of power rule here. So I'll do example E. That means this is obviously the functions being raised to the third power. So the way that this would work is I would take the limit as x approaches c of f of x, and whatever that answer is, I'm going to raise that answer to the third power. So I'm just kind of like switching where the power goes and where the limit goes. So the limit, that one was 4, right? So that would be 4. And then I would just need to do 4 to the third power, which is 64. Okay. F I'm not going to do because that was exactly like example D with the quotient rule. So I'll skip that one. G, I'm going to go back and show you. G is also an example of power rule. It's like this little added note that says that you can essentially make the radical outside of the whole limit thing. So it's like power rule where you would apply that radical last. So I'll show you what that looks like. So this would mean I have a square root, but I'm going to do the limit as x approaches c of 6 times h of x first. And actually, I'm going to also apply the constant rule. And I'm going to say, let me deal with that 6 after I apply the limit. Okay, so I can't remember what was h of x. H of x was 9. Okay, so I'm going to do my limit first, like work from the inside out. And so the limit of h of x was 9. And then I'm going to do 6 times 9 is 54. And then I would want to simplify that further, like what numbers can you divide? Hold on a second. What numbers can you divide 9 by? Uh-oh. Okay, so what can you divide 54 by? I was thinking like 9 and 6, obviously, did that up here. And 9 could go 3 and 3. So remember the singles club thing. If you have the two of the same thing, they can leave. So it'd be 3 radical 6 would be your best answer. And then H would be a lot like that one. So if you still need me to do an example, another example for you, let me know. And I can do that for you, but I'm going to skip it for now. Okay, so we're going to do these rules again, but now we're going to find all of our answers in a graph. Okay, so this is going to help you review lesson 7.1. So first thing I'm going to do is I'm going to break this up using those sum and difference rules that we learned at the beginning of this lesson. So I'm allowed to break this up and look at each limit separately, like so. Okay, so now we're going to go to the graphs to tell us what those limits are, rather than them just be given to us. So it says first, over here, what is the limit as x approaches 2 negative, which means 2 from the left side, and that is for f of x. So you have to look up here to see which graph is f of x and which graph is g of x. So my first limit is for the f of x graph. So what's the limit as we're approaching 2 from the left? So you would look here, 2 from the left gives me a y value of -1. Ooh, let me fix that. -1, actually. Okay, and then for g of x, we're also going to approach 2 from the left side. So 2 from the left side looks like it's getting closer to 3. And now you can add the answers, so your limit would equal 2. Okay, example B, I see constants and I see a difference. So I'm going to break it all up. I'm going to put the 2 on the outside, and then I'm going to also put the g of x in its own limit. That way I can look at one thing at a time. Okay, so we want the limit as x approaches 1. It does not have a plus or a minus, so that means you're going to approach 1 from both sides for f of x. So here's f of x, here's 1. So what happens when I approach 1 from the left? I hit -2, and 1 from the right, also -2, so -2 would be the limit. And then g of x, same thing at 1. I am approaching 2 from both sides, so the limit would be equal to 2. And do the math. So you get -4 minus 6, which looks like -10 to me. Okay. Remember, it is possible to get D and E for a limit, just means it doesn't exist. That also happens here with these limit properties that we're applying, so don't be surprised if you do get a limit that doesn't exist. Hopefully we'll come across one here to help you see what that looks like. So I'm going to do the limit as x approaches -3 for f of x, which is that left graph. So -3 on the x-axis is here. If I approach from the left and the right, I am meeting at the same point, which is a y value of 3. And then g of x at -3 also is approaching the same value from the left and the right. that looks like 4.